You know how everyone talks about gold, copper, or lithium, the resources that power our economy? What if I told you the biggest untapped trillion-dollar opportunity in mining is actually in the waste? The stuff everyone's been throwing away for decades, tailings. So what are tailings? Every time you extract a metal, whether it's gold, copper, nickel, or iron, the rock gets crushed and processed to separate the valuable part from the rest. What's left behind? The fine powdery residue, mixed with water and whatever chemicals were used, is called the tailings. But here's where it gets interesting. Not all tailings are created equal. Every mineral uses a different process to separate the valuable metal. For example, in iron ore or coal, it's mostly just washing and screening, using water and gravity to remove impurities. Those tailings are usually just sand, clay and rock, not toxic at all. For metals like copper, nickel or manganese, refineries use a process called flotation, where air bubbles and mild reagents help the valuable minerals float to the top. The leftover slurry still looks grey and muddy, but chemically it's quite neutral. Now, there are some tailings that are toxic, like those from bauxite, which produces aluminium. That process uses caustic soda to extract alumina, creating highly alkaline red mud. Or uranium tailings, which obviously have radioactive residues. But here's the thing, the vast majority of the world's tailings, especially from ferrous and base metal mines, are not toxic. Yet all of them are still treated like dangerous waste locked away in huge dams. There's a big misconception, which is just simply not true. Depending on how much water they contain, tailings come in a few main types. Conventional tailings are the most common, a liquid slurry that's pumped into large dams. Thickened tailings have some water removed before disposal, making them denser and more stable. Paste tailings go a step further. They're thick enough to hold shape, like wet cement, reducing the risk of dam failures. And then there's dry stack tailings, the modern standard for sustainability. These are fully dewatered using filters, then stacked in layers like sand, dramatically reducing water use and environmental risk. Each method affects how safe, stable, and environmentally sustainable the tailings are, and ultimately how easy they might be to reprocess or repurpose later on. So when you look at a tailings dam, you're not just looking at waste. You're looking at a potential resource that's been sitting there, untouched for decades. For decades, mining companies have been trying to get rid of tailings. Billions have been spent storing them safely, containing them, and reducing risk. Entire engineering teams exist just to manage tailings dams. It's such a challenge that two of the world's biggest rivals, BHP and Rio Tinto, actually joined forces. They launched something called the Tailings Open Call, a global program that poured millions of dollars into finding new ways to make tailings management more sustainable, more efficient, and cheaper. Why? Because tailings aren't just an environmental responsibility, they're also a massive cost. Building and maintaining dams, monitoring them, rehabilitating them after closure, all of that sits as a heavy line item on the mine's balance sheet. But here's the twist. While the industry has been trying to get rid of tailings, the real money might actually be in using them. First, there's reprocessing old tailings. Many tailings dams from the 60s, 70s, 80s, 90s were created using old technology. Back then, the recovery rates were nowhere near what we can achieve today. That meant billions of tons of tailings still contain valuable metals, gold, copper, nickel, just sitting there. Some junior mining companies are already taking over these old tailings assets, retreating them with modern tech and producing new concentrates without even digging a new pit. It's cheaper, lower risk, and more sustainable. But the second, and in my view, the bigger opportunity is in reutilizing tailings, finding ways to use them outside of mining. Because when you look at the composition of tailings, it's essentially finely ground sand and clay. With the right research and treatment, it can actually become a raw material for other industries. For example, used in construction as a replacement for natural sand, blended into cement and concrete, converted into ceramics, bricks, or road-based stabilization materials. And this isn't just a theory, it's something I've personally researched. When I was at university, I did a double degree in business management and civil engineering. For my final projects, I combined both worlds. I developed a full technical thesis and a business plan around the reutilization of iron ore tailings as a stabilization material for mine haul roads and cementitious material that could replace traditional quarry products completely. I built the financial model, the cost-benefit analysis, and the engineering plan to make it economically viable. Why? Because I saw this as a real market gap, an innovation that could save mining companies millions in haul road construction while turning their waste into value. After that project, I even looked into funding through Australia's CSIRO programs and private investors to commercialise the idea. But projects like this need multidisciplinary teams. Chemical engineers, mechanical engineers, material scientists, and serious funding. Even then, I still believe, and I've seen, that this is one of the biggest untapped opportunities in the entire mining sector. Because what we're really talking about is shifting mining from a linear process, mine, use, dump, to a circular one where nothing truly goes to waste. These companies that crack the code, who can make tailings profitable, won't just lead in sustainability, they'll dominate the next generation of mining economics. So why now? Because for the first time, technology is catching up with artificial intelligence, data analytics, and the evolution of early AGI level tools. Research that once took years can be now done in months. Machine learning can simulate thousands of chemical reactions or material blends to find the perfect recipe for reusing tailings. And it can do it faster and cheaper than any lab has ever done it before. In the next 5 years, the companies investing in tailings, reuse, or reprocessing technologies could become more valuable than the mines themselves. The next mining boom might not come from digging deeper holes, but from rethinking what we've already mined, from recycling, repurposing, and re-engineering our own waste. That's where I believe the trillion-dollar opportunity lies, in turning waste into wealth and problems into resources. If you like this content and you want me to continue in mine waste and recycling in the mining sector, I'm going to release a full guide of how you can actually identify and invest in the companies leading this tailings revolution. From innovative junior miners, reprocessing old dams, to tech startups creating sustainable building materials from mine waste. If you did find this valuable and you like this content, please do subscribe, share the video, because I do believe this topic needs more awareness. It's not spoken about enough within the mining industry. The world is chasing new resources, but the future of mining might already be sitting right beneath our feet, in the waste we left behind.